All right, in this example, what we want to do is utilize the Cramers rule. We're going to use Cramers rule here, since it's in the determinate kind of form, to solve a general system of a 2 by 2 general 2 by 2 system using Cramers rule, and then look at a specific example just to kind of show. Okay. All right, so the first thing I need to do is write this as a system. So my coefficient matrix will be A, B, C, D. My unknowns are X and Y, and my knowns, my column B vector is R1 and R2. Okay. So this is usually what we call capital A. This is what we call X, and this is usually what we call B, just in case that hasn't been super clear at this point. Okay. So the determinant of A is equal to A, B, C, D. So we have A, D minus B, C. Okay. And we're going to obviously assume that that's not equal to 0. Otherwise, this system is not solvable. It does not have a unique solution. So that being said, 1 over the determinant of A is going to be equal to 1 over this mess, AD minus BC. Okay. So we'll be using that in just a second. Okay. So this is our column vector. And so to find out what our unknown X is, we're going to replace this column with our answer vector here and then compute the determinant. Okay. So we have R1, R2, and BD. Okay. So we'll take the determinant of this and we get R1D minus BR2. Okay. And then so for our X value then is going to equal this, and then we're going to divide by the determinant of A. So we're going to take this and divide by the determinant of A, which gives us then that we have A, B minus B, C. Okay. So our X value then is going to equal this linear combination of products and differences. Okay. And then likewise for for Y, what we have is we're going to replace in the A matrix, the second column, we're going to replace that variable with the answer variable and then take the determinant. So we have A and C, R1, R2. Computing this determinant, you have A, R2 minus R1C, all divided by the determinant of A, which we saw earlier was AD minus BC. Okay. And so now we have, in general, the solution for X and Y. So let's imagine for a second that our system that our 2 by 2 system that maybe we're trying to solve is, let's say, X plus 2Y equals, let's say, 3, and 4X plus 5Y equals 6. Okay. So then identifying each of our components, we would have A equals 1, B equals 2, C equals 4, D equals 6. No, sorry, 5. And R1 equals 3, and R2 equals 6. Okay. So if we plug these values into each of our values here, okay, for this specific example, okay, what we find is X is equal to R1 was 3 times D, which was 5, minus B, which was 2 times R2, which was 6, divided by the determinant, AB. A is 1, D is 5, minus B 2 times 4. Okay, and so that's 15 minus 12 over, and this is 5 minus 8. All right, 5 minus 8. 5 minus 8. Okay, so this is 3 over -3, which gives me -1. Okay, so X is equal to -1. And likewise, we plug in for Y, we have A is 1, and R2 was 6, minus R1, which was, I think, 3. Yep, and C, which was 4. divided by, and we saw a d minus bc, we saw that that was a negative 3. We already calculated that. This is 6 minus 12, so this is a negative 6 divided by a negative 3. 6 minus 12 is negative 6 over negative 3, which gives me a positive 2. Okay, so this solution says it's negative 1, 2. Let's plug it in just to see if it works out. Okay, so up here we have negative 1 plus 4 gives us 3, check. Negative 4 plus 10 gives us 6. Okay, so that is indeed the solution, and that is what we were hoping to find. I hope this was helpful, and I look forward to seeing you in the next video.